distribution on different objects. So basically there are two types of charge distribution. One is the discrete charge distribution or discontinuous charge distribution, and the other one is the continuous charge distribution. Now how do we categorize these two types of charge distributions? So the first type of charge distribution is discrete charge distribution, and this type of charge distribution usually happens on the surface of insulators. The reason is because of the low conductivity of the insulators. So let us just start off with a discrete charge distribution and how it happens. Suppose let us say we have charged the insulator at this position. That is, we have added or removed some electrons from this position. In this case, since I have taken positive charges, it means that I have removed the electrons from this particular region of the insulator. So what happens is the positive charges are accumulated in this place. These charges which have been accumulated over here, they do not move to other regions. The reason is because of charge localization. That is, they are not capable of moving to other regions of the insulator. Thus, in the same way, when I charge the insulator over here, or over here, or over here, or over here, or over here, the charges localized wherever they are actually put on the surface of the insulator. This kind of charge distribution, we call it as the discrete charge distribution. Now coming to the next one, that is the continuous charge distribution. It happens most of the times in case of the conducting materials. So first type of charge distribution is the linear charge distribution. In this case, whenever I charge a linear conductor in the sense if I take a thin wire or thin rod, metallic rods, that is of let's say length L, and I put some charge Q on it, then I can see that the charges will be distributed uniformly all over the length of the conductor, and this happens so that the charges will be experiencing minimum electrostatic force between them. Now the linear charge distribution can be mathematically identified by the quantity called as linear charge density, and this linear charge density is given by lambda equals to Q by L. Lambda is the notation used for linear charge density. Q is the total charge put on the conductor, and L is the length of the conductor. The unit for this would be coulomb per meter. The linear charge density has a unit of coulomb per meter. Now coming to the next type, that is, if I am going to take two-dimensional objects like let's say metallic sheets, or if I am going to take a three-dimensional object like a spherical shell, in such cases, if I am going to charge these objects, the charges will get uniformly distributed all over the surface of the objects. That is, they will be equally placed all over the surface, and this kind of charge distribution we call it as the surface charge distribution. This is also a type of continuous charge distribution. Now if let's say this is a square sheet on which I have actually charged, then I take, if the surface area is A, then this surface charge distribution can be identified by a quantity called as surface charge density, which is given by sigma equals to Q by A, where sigma is the surface charge density notation, Q is the total charge on the surface, and A is the surface area of this particular metallic sheet. Now coming to the third type of continuous charge distribution, it is called as the volume charge distribution. Let us say we have taken certain amount of charges within an enclosed surface. In such a case, the charges will be distributed all over the volume or throughout the volume of that particular enclosure, and this kind of charge distribution we call it as the volume charge distribution. If let's say the volume of this enclosure is V, then the volume charge density, which is going to represent the volume charge distribution, will be given by rho is equal to Q by V, where rho is the volume charge density, Q is the total charge inside this volume, and V is the volume of this enclosure. So this is about the charge distribution. Now this charge distribution is very important as it gives us a tool to apply what is called as the Gauss theorem. A of course, while finding the electric field associated with the system of charges, it is very much easy to use the Coulomb's law, but Coulomb's law, it has its own limitations when it comes to the practical applications. So to overcome the to overcome the limitations of the practical application of Coulomb's law, we go for the next theory, which we call it as the Gauss theorem.